In this problem set, we're going to practice drawing different versions of cyclohexanes. For the first part, we're going to start with perspective drawings, draw a chair conformation, and then show the ring flip to the other chair conformation. So as we go through these, I will deliberately talk about the different aspects of the drawing and why we are keeping track of certain things, and you will see how it all falls into place. So as long as you follow the strategy consistently, then you will find that you are less likely to make mistakes with this. Okay, so for the first problem, we have the perspective drawing of a monosubstituted cyclohexane. Okay, so all you have to remember is whether the substituent is pointing up or down. So for this example, I think it's useful to keep track, again, of whether the substituent is pointing up or down. And also, so we'll just write up here. And also, you want to number your carbons so that way you can keep track of them when you get to the chair form and then the other chair form. So this carbon, if we're going along with our nomenclature rules, must be carbon 1. And I'm just going to number the carbons 1 through 6 around the ring like that. Okay, so we know that on carbon 1, on C1, we have the substituent that is facing up. Now, when we go to draw the chair form, the first chair form, we're going to draw a generic chair structure the same way every time. So when I say generic chair, I mean you draw the chair, you draw all of the bonds, you draw all the axial bonds, you draw all of the equatorial bonds, and then you put the substituents where they need to go. So no matter what, draw all the bonds in the same way every time for the chair form. So remember, when you draw the chair form, you first start with one set of parallel lines. And there are different ways to draw these. Different books use different approaches. This is one that I use that I think works and allows you, again, to keep track of what's going on. So the version that I'm drawing first shows the lines slanting in this direction, first set of parallel lines. Second set of parallel lines shows a line moving down from there and a line moving up from there. So these two are parallel. And the third set of lines simply connects those last two bonds in order to close the ring. So that's the first thing. So you always draw the chair and then you draw all the bonds. So when you draw the bonds, so I'm just going to start here, and you'll see that I'm pretty consistent in how I do this. The first bond we draw up, and then you alternate up, down, up, down, up, down. So the bonds that point in the vertical direction, those are the axial bonds. So the first axial bond is up, second one is down. Third one is up, fourth one is down, fifth one is up, sixth one is down. Always the same. It never ever changes. And you'll see a slight difference when you switch to the other conformer, but we'll get there in just a bit. Second thing you do is you fill in all the equatorial bonds. So the equatorial bonds are the ones that are slightly horizontal, but you'll see that they also kind of have an up or a down trend, just not quite as dramatic as these vertical bonds. So since the axial bond is up, so again, starting with this carbon, the equatorial bond slants down a little bit. And then we do that same alternating. So if this one is down, this one is up. This one is down, and for these that are sitting in those V's, the equatorial bond will point towards the closer carbon. In other words, it points here, not here. Okay, coming over here, since this one was down, this one is up, this one is down, this one is up, pointing towards the closer carbon, like that. So we've got the chair form of the ring, we've got all the bonds. The next thing we need to do is number the carbons. And it really is arbitrary where you start carbon 1. I generally start carbon 1 up here, if that's available. Sometimes it depends on what information is given, but in this case, I can start that numbering where I want. 1, 2, 3, 4, 5, 6. So that was a lot of talking to get to the point where we have the generic chair. So that is a generic chair form. Now we need to add the substituents. So all we do is look at what we already knew. So we already could clearly see, because of the wedge, that this substituent on carbon 1 is pointing up. So all we do is look for carbon 1 and put the CH3, put the methyl group pointing up. Carbon 1, right there. We have two choices, the up or the down. So when we go to write the substituent, we just need to pay attention to what is happening over here at our original structure. So if the substituent of carbon 1 is pointing up, that part stays consistent. That doesn't change, even though you will see when we go from one chair form to the next that which bond that substituent is on, axial versus equatorial, that will change. Okay, but this doesn't change. So we just go to carbon 1, we find the bond that's pointing up, and we write that in. And that's all we have to do for that. So the next step is to draw the ring flip. So ring flip is just the physical process that the atoms in the ring go through in order to, I guess you could say, distort the ring into the other chair conformer. There's a pretty deliberate process by which this happens, but for right now we're just going to really be concerned with how to draw it. Now if I had more room here, you would be, and I'm going to have to draw this underneath, you would see that the ring and the bonds, not the substituent, but just the generic form of the ring, is going to appear as a mirror image. So that tells you that you've drawn the generic chair form correctly. And then it's just about looking for those bonds. There's one more trick that we have to worry about, but let's draw the ring structure first, put in all the bonds, number the carbons, and we'll talk about this extra thing you need to worry about when we're numbering the carbons. Notice how the first form of the conformer, the slant was in this direction. If it's going to be a mirror image, the slant needs to be in the opposite direction. So again, I have to draw it underneath here, just in the interest of space. So there is our first set of parallel lines. For the first conformer, we started from the top on the first line and from the bottom on the second line. This is just, again, reversed. So the second line goes like that, the second line goes like that. So if you were to imagine these side by side, it would be a mirror image. And then the third set of parallel lines, it's kind of crooked, but anyway, the third set of parallel lines closes the ring. That's the first thing. Second thing, we're going to draw all the bonds, all the axial bonds, then all the equatorial bonds. So we're just going to start up in this upper corner. First one up, second one down, up, down, up, down. And you'll start to get into a routine with this, and you'll be able to sketch these out very quickly. Second set, go through, draw the equatorials. Again, this first one was up, so this equatorial bond is slanted kind of down, then up, then down. Remember that those equatorials that are at those V's point towards the nearest carbon. And again, if you can imagine this up here, this one is pointing like that, and that one is pointing like that. So it is a reflection, it is a mirror image. Continuing, this one was down, this one is up, down, up, pointing towards a closer carbon. So we've sketched all of the bonds, and now we need to number the carbons. Here's the thing that you have to be careful about, because in the process of ring flip, and if you have a model set, you should build the model and bend the carbons, and you'll see how this works. But this carbon pulls down, and this carbon pulls up in the process of ring flip. What you have to remember is this is carbon 1, but because you pull it down, carbon 1 is no longer this upper corner, it is down here. This is 2, this is 3, this is 4. Okay, that makes sense. What I said was carbon 4 flips up. There's carbon 4 flipped up. 5, 6. Okay, if you forget that, then everything will be completely messed up, and later when you go on to make some other predictions about the stability of a given conformer, then your predictions will be off. So you want to be really deliberate about where those carbons are numbered. Okay, and now we had our substituent on carbon 1. coming back to the original perspective drawing, the substituent, the methyl, was on carbon 1 and it was pointing up. So we have to retain that. We find carbon 1, we find the bond that's pointing up. And notice, in this case, it's now not an axial position, but an equatorial position. And that's the other thing that's worth remembering, is when the ring undergoes ring flip to the other conformer, all bonds that were axial will automatically end up as equatorial. And all bonds that were equatorial end up as axial. That will always be the case. And again, in case you might forget that, it comes back to this consistency that must be. That bond must still be pointing up, or in other words, out of the page. So here's a model of cyclohexane, and in a chair conformation. So I'll try to line this up. Okay, so we're looking straight at this set of parallel lines, and so then you can see the part that is pointing down, and then the carbon that was pointing up. For the carbon over here, that is, I guess, the top of the chair, I put one axial bond. And so I want to show you what happens with ring flip. So again, with ring flip, this bond over here is going to pull up, and this bond here is going to pull down, and we're going to have the other conformation of the chair. So this one pulls up, this one pulls down. Make sure our lines are parallel. And when you look at this, notice how that bond now, so this one had pulled down, that bond is now not axial because the axial bond would be down here. That bond is equatorial. If we go back to the other version of the ring flip, pulling that one back down, so this is the original version that we had. Notice how that bond that we just looked at went from the axial position, the bond that we just looked at went from the equatorial position that was more horizontal-like, and upon ring flip, it points to the vertical position. For the next problem, we're starting with the perspective, and this time we have two substituents. So although the numbering could technically be arbitrary, because then all you're trying to do is translate that carbon numbering to the first chair form and the second chair form, following all of the rules, I think it's a good idea to keep in mind the nomenclature rules and assign the carbon numbers to what they really should be. So, in other words, the OH group should have a lower carbon number than does a halogen. So in order to number this correctly, the OH really should be on carbon 1, and the chloro, or the chlorine, should be on carbon 4. Even if you switch these, the relative positions, up, down, or axial, equatorial, that you end up with your final drawings, those relative orientations will be the same, and so it really doesn't matter. This is just sort of a nitpicky nomenclature issue. So we're going to follow the same guidelines that we followed in the last problem. We're first going to start by recognizing how the substituents are positioned relative to what seems to be the plane. On carbon 1, the hydroxide is pointing up or out of the plane towards us, what seems to be a plane. And carbon 4, the chlorine group with the dash, is telling us that that is pointing down, in other words, away from us. So at C4, that substituent is pointing down. I think it's a really good idea to keep track of these at the beginning, so that way when you get all wrapped up in these chair conformations, all you have to do is look back over here when it was easy, and it all makes sense, and you will not make a mistake. So we're going to draw the first chair conformation. So we'll start with our first set of parallel lines, the second set of parallel lines, and third set that closes the ring. You'll get pretty fast at drawing these. Second step, draw all of the axial bonds starting over here, up, down, up, down, up, down. See how fast we are at this? Second set of bonds, the equatorial bonds, This one will start with the slight downward angle. So down, up, down, pointing toward the nearest carbon, up, down, up, pointing towards the nearest carbon. So you can see that with practice, you can draw this generic chair form in about 10 seconds and get a reasonably accurate depiction of the angles. Second thing we need to do, number the carbons. You can actually number the carbons before you draw the bonds, but I find if I do that, then my bonds run into the numbers, and so that's just a sort of a formatting issue, but it doesn't matter. But you still need to draw all the bonds, and you need to number all the carbons, and now we've got our generic chair. Next thing we need to do is make it not generic and actually add the substituents at the proper carbons. So on carbon 1, we have an OH group pointed up. So that's all we do. We just look for what we're supposed to do. We find carbon 1. We're going to put that OH group pointing up. That is all there is to it. The other substituent is a chlorine. So we locate carbon 4 and the down position. So there's carbon 4. The Cl is pointing down. So you can see that even though we had one up, one down in the original perspective drawing, we still have one up, one down. It just so happens that they both end up on axial positions. The next thing we need to do is draw the ring flip. So we're going to follow the same process. We're going to draw our second set of initial parallel lines pointing in the opposite direction. Remember, the generic chairs appear as mirror images. The substituents, the specific substituents, will not appear as mirror images, so don't get confused by that. So we've got our first set of parallel lines, second set of parallel lines, third set of parallel lines to close the ring. We're going to write in all the axial substituents. Keep making that one too long. So up, down, up, down, up, down. And then we'll write in the equatorial bonds. Down, up, pointing the nearer carbon, up, pointing to the nearer carbon. And then we'll number the carbons. Remember that whatever the carbon this is, it doesn't matter if we numbered this carbon here as 1, 2, 3, it doesn't matter. Whatever that is, it pulls down and it becomes this carbon. If this had been carbon 6, this is carbon 6, and then you'll finish the numbering sequentially as needed. But this just so happened that that was carbon 1 again, so there's carbon 1, 2, 3, 4, 5, 6. So now we have the ring flip version of the other conformer of the chair, and now all we have to do is put the substituents where they need to go. Remember that the OH group is on carbon 1 pointing up, so we find carbon 1, we find pointing up, and we just write it in. The chlorine is on carbon 4 pointing down, we find carbon 4, we find pointing down, and there's that one. I should have technically drawn the double arrows up here, a little bit delayed in that, because these two forms of the chair are in equilibrium. So it's going back and forth, back and forth, back and forth. So by now you're starting to get an idea of the process, and you can see that we're basically going through the same steps every time. And that consistency is really going to help you out as you continue to draw these. Or again, when maybe you have to draw them in an isolated situation. You're just shown one structure and you got to whip out a chair conformer and then say something about it. You can't say anything about it that means anything unless you can draw it properly. So here we have two substituents again. It's a di-substituted cyclohexane. We're going to number the carbons. Again, if we were following our nomenclature rules, the ethyl would be at an earlier carbon than the methyl, giving the substituents on the lowest set of numbers. So the numbering would be in that way. We recognize, the next thing is to recognize whether those substituents are pointing up or pointing down on C1. Dashed line, that's all we're doing. We're just looking at the dashed line. dashed line tells us it's pointing down. On the other carbon, on carbon 3, dashed line tells us it's pointing down. But I really think it's a good idea to make note of this, so that way you don't even have to think about it when you get to the other side, when you get to the chair conformation. You just come back over here and you look and say, okay, I already figured that one out. We're going to draw our first chair. So there's our first set of lines. There's our second set of lines. And then closing the ring. We draw all of our axial positions. Up, down, up, down. You can see it's starting to get boring, but that's okay. That means it's getting easier. We now draw all of the equatorial positions. So down, up, down, up, down, up. And then we number the carbons. So I'll continue to be boring and number them in the same way each time. So there's 1 through 6. There's our generic chair. After that, we just need to write the substituents on the proper carbon numbers and pointing in the right direction. So the ethyl group is on C1, pointing down. Here's C1. The position that is pointing down is the equatorial position. So we write the ethyl group there. And on C3, we have a methyl group also pointing down. On C3, the methyl group is pointing down. And you notice that it just so happens in this chair conformation that they're both in the equatorial positions. There's not an easy way to predict when you start here, go, oh yeah, I know that'll be axial or that will be equatorial. Don't even try to make that prediction. Just go through the process, and then once you have drawn it, it will make sense. Okay, now we're going to draw the ring flip. So we'll draw the other conformation of the chair, drawing those lines in the opposite direction. Second set of parallel lines, and then closing the ring. Write all the axial bonds, alternating up, down, and then fill in all the equatorial bonds, down, up, down, up, down, up. And then the next thing we do is we number the carbons. Remember that this carbon that I have numbered 1 pulls down, so that carbon number 1 is now in this position. And then we just go through and number the carbons all the way around. Hopefully you're starting to find that this is getting easier and easier as you see this over and over again. And then the last thing that we need to do, we're almost done. See how fast this goes now? All we have to do is put the substituents on the carbon number in the direction that they need to be facing. So the ethyl group is on carbon 1, which is over here, and it's pointing down. The methyl group is on carbon 3, and it's pointing down. In our original chair conformation, our substituents were both in the equatorial positions. And notice upon ring flip to the other conformer, they both end up in the axial positions. That will always be the case. And so sometimes you can tell if you've done the ring flip incorrectly because you can very clearly see this is equatorial. If it ends up equatorial over here, then you've done something wrong. And so it's just an opportunity for you to check the positions of the bonds and the carbons and all of that. So for this example, we have 2 of the same substituent. So one of these will be carbon 1, one of them will be carbon 2. It doesn't really matter. And the other thing we notice is that they're both pointing in the up direction. So on C1, we have the bromine that is pointing up, and on C2, we have the bromine that is pointing up. Okay, so we just want to keep track of that, and then we'll draw the first chair. So the first chair has our first set of parallel lines, second set of parallel lines, and the third set that connects or closes the ring. Then we're going to add our axial bonds. So we just start with this carbon up in the corner. First one up, then we alternate down, up, down, up, down. And then we write in the equatorial bond. So again, starting at this first carbon that's pointing up, since the first bond we wrote, the axial bond is pointing up, then the equatorial must be pointing down. So once you have those reference points anchored, then it's just alternating. So this one was down, that one's up, this one's down, pointing the nearer carbon, that one's up, that one's down, floating in air. Let's try this again. That one's down, that one's up. The numbering is arbitrary. From the previous examples, you've seen that I always start number 1 here, and that's just habit. It doesn't have to start there. You will always get the same relative positions of the substituents when you go to look at both conformers. So it doesn't matter. So don't be distressed if for some reason you can't number this one as number 1. For whatever reason, it doesn't matter. Even if I number this one number 1 and go through the ring, go through that sequence of the numbering, relatively speaking, the substituents will end up in the same orientations. And so there's no worry about making a mistake as far as that goes. But creature of habit, I'll start carbon 1 up there and number around the ring. So all I have to do now is go to carbon 1 and carbon 2. I have the same substituent pointing in the same direction, so that makes it really easy. So for carbon 1, I have a bromine pointing up. For carbon 2, I have a bromine pointing up. So notice that for carbon 1, that pointing up was an axial bond, but for carbon 2, pointing up is an equatorial bond. Now remember from the reminder last time, and that is that when you undergo the ring flip, all of the axial bonds turn into equatorial, and all of the equatorial bonds turn into axial. So let's draw the ring flip, follow our process, and see if, in fact, that's what we end up with. We should end up with that if we've done the drawing correctly. So we drew the 3 sets of parallel lines, start from this upper corner, drawing the axial position up, and alternating up, down, all the way through the ring. Down, up, down, up, down. Starting from that upper corner, the equatorial bond points slightly down because the axial bond was pointing slightly up, and then we alternate going all the way around the ring. So now this one was down, pointing towards the nearer carbon, up, pointing towards the nearer carbon. I haven't mentioned this in a couple of examples, but remember that the generic forms of the rings of these 2 chair conformers look as the mirror image if you ignore the substituent. So just those generic forms, the way those bonds are pointing, nothing is attached to them, but the way those bonds are pointing are mirror images of one another. And again, that's a checkpoint. If one of the bonds is pointing not in a reflective manner, then that tells you that something isn't drawn correctly. Oh, we should number the carbons. So remember, this carbon pulls down, becomes this carbon, so that one becomes number 1. And we just number those all the way around the ring. And then we just put the bromines on the correct carbons in the correct orientation. So both bromines are pointing up. So the bromine on carbon 1 is pointing up. That's the bond on carbon 1 that's pointing up. And then the bromine on carbon 2 is also pointing up. So the bromine on carbon 2 ends up there. If we take a look at the axial versus the equatorial and what happens upon the process of ring flip, bromine 1 was axial and bromine 1 turns into equatorial. So that's okay. Bromine 2 was equatorial, bromine 2 turns to axial. So we independently can check that after we've drawn these, just going through the drawing process and following those rules, but that tells us that we likely have drawn it correctly. So the last problem that we have going from perspective drawing to chair and then the other chair is another dye substituted ring. So these are spaced evenly, they're the same substituent, so the numbering, we just start at one of the methyl groups, and it doesn't matter in this case, you can double check the numbering, it doesn't matter in this case which one is one and in which order around the ring, or I should say in which direction around the ring we go. They're still going to end up on the 1 and the 4 respectively, or comparatively. So the next thing we have to do is take account of the substituents and in which direction they are pointing. So the methyl on C1 is pointing down. The dashed lines indicate that. And the methyl on C4 is pointing up. So we'll use that information just to place the substituents once we draw the chair form. So drawing our last chair form, at least for this set of the exercises. So we draw the first set of parallel lines, second set of parallel lines, third set of kind of parallel lines closing the ring. Starting in this upper corner, the axial starting up, alternating around the ring, up, down, up, down, up, down. And then the equatorial starting in this upper corner, starting in the down position, down, up, down, pointing towards a closer carbon, up, down, up, pointing towards the closer carbon. And then we number the carbons. So 1, 2, 3, 4, 5, 6. And then we look at our notes over here, and we have a methyl group on C1 pointing down, and a methyl group on C4 pointing up. So the methyl group on C1 pointing down must be the equatorial position, because that is the bond that is pointing down. And the methyl group on C4 is pointing up. That is also the equatorial position. Again, difficult to predict going from here to here, so don't even bother. Just follow the rules, sketch the bonds how they need to go, and then put the substituents in the direction they need to be, whether that's up or down. We'll draw the ring flip. So now our initial set of parallel lines is pointing in the opposite direction. Remember, the generic form looks as a mirror image. We draw the second set of parallel lines, and then the third set to close the ring. Starting in the upper corner, we write the axial bond up, alternate up, down through the ring, up, down, down, up, down. And then we write the equatorial positions, again going to this upper corner. That one starts pointing down, up, down, towards a nearer carbon, up, down, up, pointing towards a nearer carbon. This carbon that's pointing up, in the first chair conformation, it pulls down, and so becomes carbon 1 there. And then we will just number the carbons sequentially from that anchored position of carbon 1. And then the last step is just to put the substituents on the carbon numbers in the right orientation. So the methyl on C1 is pointing down. So that's the bond that's pointing down. And the methyl on C4 is pointing up. That's the bond that's pointing up. We'll do one more check. So when we go to the first chair conformer, both methyls were pointing up or down as they needed to be, but it turned out that they were both on equatorial positions. When we do the ring flip and go to the other conformer, notice that this equatorial turned to an axial and this equatorial turned to an axial. So that secondary check that we've been doing works out. For the second set of examples, we're going in the opposite direction. So we're starting with a chair conformation. It might be this version, it might be the ring flip, but we're starting with a given chair conformation. We're going to draw the ring flip, and then we're going to draw the perspective drawing. And so we'll do something similar to what we did previously, And that is, well, so first of all, notice that all of the bonds weren't drawn here. So you need to get used to that view, even though when you draw any chair conformation, you're going to draw all the bonds, all the axials, all the equatorials, just like we saw. So that way you don't ever mess up what those orientations are. So what a couple things we're going to do to sort of set this one up so that way we can draw the ring flip. We're going to notice if these substituents are pointing up or pointing down, because remember, that part of it will not change. And that is the part that we need when we go on to draw the perspective drawing. So notice here, actually before I do that, let me go ahead and number the carbons. And you're going to find with some of these examples that this carbon that's pointing up, that I had always numbered 1, might not always be 1, because we want to number the carbons correctly as far as the nomenclature rules. Turns out it's my lucky day and I can still number that one as number 1, because then the substituents are on the lowest set of numbers, which is 1, 2. It actually doesn't matter if I numbered this one 1 and this one 2, or this one 1 and this one 2. You're going to find the same information reflected in the composite in both versions of the chair positions. So it really doesn't matter, and I think that's important to note because there are a lot of things that do matter. This happens to not matter. So we number the carbons. Second thing we do is we're going to take account of whether those substituents are pointing up or pointing down. If I go ahead and just draw for these 2 carbons only that have the substituents attached, if I draw the other bonds, just for completion's sake, just in case it wasn't clear before, it should be clear now in which direction these bonds are pointing. So I think the axial position is fairly obvious. So on C1, the chlorine is pointing up. I don't think there was any uncertainty there. But here, if you didn't recognize that that was equatorial, then that could be confusing. But once we draw the other bond in and see the axial that is clearly pointing down, then there's no doubt that the C2 substituent, the C2 chlorine, is pointing up. So that only takes a few seconds, maybe 10, 15 seconds to number those carbons and identify up or down, and then a lot of that work has already been done. The next thing we're going to do is the ring flip, and so you will get to see these side by side in this next set. So the first thing we're going to do, draw the generic chair. We're not even going to pay any attention to what's going on over here, and I think that's really important. We're just going to draw our chair. Okay, we've drawn a whole bunch of these. We know how to draw them. And then we're going to write the bonds in. So you'll probably have dreams about this because you've drawn so many of them. You just know how to do this. There are all of our axial bonds. And then we're just going to sketch in the equatorial bonds and not even worry about it. So there's our generic chair in the ring flip conformation. Now the one thing we do have to be careful about, just like with the other ring flips that we did, is we have to make sure that whatever carbon number is in this pointed up position pulls down and is the carbon number over here. And so again, this was not creative, 1 and 2, just like I had done previously, but you want to be cautious to actually note what is that carbon number so you don't make a mistake later on. But for now, not being very creative with this, it's following the numbering scheme and the position that we've already seen. Okay, so to draw the ring flip then, we just have to find what we have. Turns out they're both chlorines. Put them on the right carbon number and point them in the direction that they already were. So for carbon 1, we have a chlorine that's pointing up. For carbon 2, we have a chlorine that's pointing up. Now we can take that other check, make that other check, and see, do the axial and equatorials switch? Well, this one was axial on C1. It turned to equatorial. On C2, we had equatorial that turned to axial. So that part of what happens in ring flip works out. The last thing that we need to do here is draw the perspective drawing. So we're just going to draw our hexagon cyclohexane. We can number these carbons wherever we want because we are going to put the substituents on the carbons where they need to go. And then we just pay attention to whether those substituents are pointing up or down. If they're pointing up, we draw a wedge. If they're pointing down, we draw a dash in order to show the perspectives of those bonds. These are both pointing up, so on both carbon 1 and carbon 2, we draw the wedge, indicating that those substituents are pointing up out of the ring. And then on carbon 1, actually the substituents are the same, so we have the chlorine on carbon 1 and the chlorine on carbon 2. So for this example, again, we're starting with a chair conformation, and you might notice that it is the ring flip version of the way that we started the last problem. And that's a good thing because it forces you to start at different locations, but hopefully it shows you that you go through the process in the same way, that strategy is the same, and you will end up with the right answer. So in this case, and the other nice thing about this example is it prevents me from numbering this carbon as carbon 1. If I number the carbons according to where the substituents go, then I either need to have this one 1 and this one 3, or reverse. So in this case, I'll just number this carbon as 1, 2, 3, and number all the way around the ring. So I have my sequential numbering. So the other thing that I'm going to do is I'm going to go ahead and sketch the second bond on each of these carbons that has the substituent attached, just so we can clearly see in which direction that substituent is pointing, whether it's pointing up or pointing down. So we see on carbon 1 that the ethyl group is pointing down, and we see on carbon 3 that the ethyl group is pointing up, because in this case the axial bond is pointing down. So in this case that equatorial bond is pointing up. Still not that creative with the substituents, but that's okay. We have a lot to keep track of with regards to the numbering. And so the next thing that we're going to do is sketch the ring flip. So remember that the ring flip is, in its generic form, a mirror image of what we saw here. So just make sure that you pay attention to the fact that the first set of parallel lines is pointing in the opposite direction than the way I normally draw them. And that's okay. We're just going to draw them then in the opposite direction. So there's the first set, there's the second set, and then the third set closes the ring. For this version, we're going to draw all of the axial and equatorial bonds, because again, we don't want to try to figure stuff out. We want it to be laid out for us as completely as possible, so then we can just sort of fill in the blanks. Every once in a while you have that option, and you should grab that option when it is available to you. So there are all of our axial and equatorial bonds. The next thing that we need to recognize is what is happening with this direction of ring flip. In this case, carbon 4 pulls down and carbon 1 pulls up. So those carbons are moving in those directions, and so what that means is carbon 1 ends up here and carbon 4 ends up down here. So everything is shifted by 1. So this is 1, 2, 3, 4, 5, 6. So everything is just shifted in this direction by 1 position. And that is consistent with what we saw before. It's just going in the reverse fashion. And then the last thing that we need to do here is put the substituents on the proper carbon numbers, pointing in the right directions. So both substituents are ethyl groups. The ethyl on C1 is pointing down, so I find I find C1, and the ethyl goes on the bond that is pointing down, and the ethyl on C3 is pointing up. And the last thing I do with this before I check the perspective is I make sure that axials and equatorials switched. So C1 was axial, C1 becomes equatorial, C3 was equatorial, and it becomes axial. So our ring flip is done correctly. And then the final part of this exercise is to draw the perspective drawing. The numbering can be wherever we want because we are placing the substituents where they need to go. The only thing that we really need to keep track of is whether those bonds are up or down. So the bond on C1 is facing in the downward direction, so we draw that as a dash. And the bond at C3 is pointing in the up direction, so we draw that as the wedge. And then filling in the substituents themselves, they're both the same. Try to keep my color coding consistent. And there's our perspective drawing. So for this chair conformation, we actually have 3 substituents, and we need to keep the numbering all together, so they will just be in order of 1, 2, 3. There's no preference whether we started this one 1 or this one 1. Everything it basically ends up to be the same. So we'll go ahead and start this. This carbon is 1, 2, 3, 4, 5, 6. So this gives you another opportunity to see what happens with the ring flip and so on when we're not always starting the same carbon as number 1. The next thing we're going to do here is go ahead, just as I've done with these other drawings, and draw the other bonds in place just so we can very clearly see in which direction each substituent is pointing, and then we're going to keep track of it. So at carbon 1, we have the methyl group that is pointing down. I know it might seem like a waste of time to note this every time. I don't think it's a waste of time. I think it makes it really easy when you go on to the next step, and it's worthwhile. Carbon 2, the substituent is also pointing down. And then for carbon 3, which we didn't have before, this substituent is pointing up, this equatorial position, because it's the axial position that's pointing down. So C3 is pointing up. We're then going to draw the ring flip and draw the generic chair where we put every axial and equatorial bond, and then we just have to move these substituents to the proper carbon number and in the proper orientation, whether up or down. So take a look at the slant of that first set of parallel lines, and then make sure that you draw the slant of the new first set of parallel lines pointing as a mirror image. And then we draw the second set of parallel lines and the third set of parallel lines. Put all the bonds in so that part doesn't change. Even though our carbon numbers changed, how we draw these bonds is starting to get boring because it doesn't change, and that's okay. So there's our generic chair that, at least at first glance, is a mirror image of the first chair. The next thing we need to do is number the carbons. So remember that when this chair is pointing like this, when the parallel lines are slanting in this direction, in order to do the ring flip, this carbon that is up here pulls down, and this carbon that's over here pulls up. So this carbon pulls down, that's carbon 2. So carbon 2 is going to be in that downward position, and then the numbering goes all the way around. But if we wanted to take stock of this one, carbon 5 pulls up. This should be carbon 5, and the numbering should work out. So there's 2, 3, 4, 5, 6. That makes that one carbon 1. So we've written all of the axial and equatorial bonds. We've numbered the carbons correctly. And then the next thing that we need to do is simply put the substituents on the proper carbon numbers in the proper direction. So on C1, we have a methyl pointing down. C1 pointing down, methyl. On C2, we have a bromine pointing down. C2 pointing down, bromine. And on C3, we have a methyl pointing up. On C3, methyl pointing up. We'll double check our axial versus equatorial. On C1, axial goes to equatorial. That's fine. On C2, we have equatorial that turns into axial. And then on C3, we have equatorial that turns into axial. So those conversions ended up being correct. And then the last part, the final part of this example is to write the perspective drawing. And here we just have to pay attention to whether the substituents are up or down. On carbon 1, the substituent is facing down. On carbon 2, also facing down. And on carbon 3, facing up. So for carbon 3, we write the wedge. And then we just write the substituents on the proper carbons. So on C1, we have a methyl pointing down. On carbon 2, we have a bromine pointing down. And on carbon 3, we have a methyl pointing up. So at first glance, this next example looks a little bit funny, but you just simply need to recognize that the substituents are drawn in line angle fashion rather than in condensed form, such as CH2, CH3. In order to properly number the carbons, we should identify what those substituents are. We know they're on the 1 and the 2, or the 1 and the 2, but we just have to figure out which is which. And so notice that this is an isopropyl group, whereas this is a propyl group. So if we were to go through the nomenclature rules, the isopropyl, the I is alphabetically before the P for the propyl, so that means that the isopropyl is on carbon 1 and the propyl is on carbon 2. Let's go ahead and complete the numbering around the ring. And then, just to be consistent with the way that the other examples were drawn, let's go ahead and sketch the other bond just so we can very clearly see whether those substituents are in the axial, equatorial, up, down, whatever they happen to be. So on carbon 1, the isopropyl is in the downward position. Because it's in the equatorial position, the axial direction is clearly up. And the propyl group, which is this one, is clearly in the downward direction. And it turns out that it's in the axial position. We only have 2 substituents to deal with, so let's go through the ring flip. The original slant of the parallel lines was in this direction, so the slant of the parallel lines will go in the opposite direction. And then we draw the chair. It's looking less parallel as the day goes on, but I think you get the idea. The next thing we need to do is put in all the axial and equatorial bonds. So by now this is old news. You just know how to do this. Hopefully this is becoming automatic and easy. That's the goal. Okay, so there are all of the axial and equatorial bonds. And then the last thing you need to really do need to pay attention to this, and that is which carbon number ends up as which carbon number, I should say, which carbon number ends up in which position over here. So you need to keep track of what the ring flip bending of the atoms, what that's doing. So notice that that carbon pulls up, that carbon pulls down. So carbon 6 pulls up, carbon 3 pulls down. So this one up in the corner that I labeled number 1 forever and ever actually is carbon 6, and carbon 3 ends up down here. So then this is 1, 2, 3, 4, 5, 6. Okay, so we've got our numbering, we've got the numbering of our carbons. Everything just shifts over by 1 carbon. And then the last thing we need to do to complete the ring flip is put the substituents on the right carbons pointing in the right direction. So on C1, pointing down, we have the isopropyl. So on C1, pointing down, we have the isopropyl. And on C2, pointing down, we have the propyl. So on C2, pointing down, we have the propyl. Notice that, so this is a little bit tricky to see. This is an equatorial bond. It's just hard to see that clearly because of the way that that long propyl group is. This one is clearly axial because you can see that equatorial bond here. So I just want to make that comment as far as how the ring flip turns out. So the last thing that we want to do is to make sure that the axials become equatorials and equatorials become axials. So C1 is equatorial, it ends up as axial. C2 is axial, and it ends up as equatorial. So that part turns out to be okay. So the last thing that we need to do with this problem is sketch the perspective drawing. So we write our cyclohexane, number the carbons, and then determine in which direction the substituents are pointing. So carbon 1 is pointing down. We draw that as the dash. Carbon 2 is also pointing down, so we will also draw that as a dash. The isopropyl is on C1. It's a little bit funny to draw it this way, but that first part of that bond is pointing down. So you draw that as a dash, and then you kind of show the other carbons. If you don't like that with the line angle, then you can show that pointing down and then actually sketch that out as a condensed formula. That makes you feel better. And then for the propyl, the same idea, also pointing down. So I'll just write that out similarly. Finally, we have made it to our last problem. So we're starting with this version of the chair. We need to number our carbons. So we have a chloro on one carbon. We have a fluoro on the other carbon. Alphabetically, chloro will be first in the name. And so that should be carbon 1, since 1 versus 2 doesn't really matter. So 1, 2, 3, 4, 5, 6. I'll also just sketch in the other bonds on the carbons of interest that have substituents attached. And then we will indicate whether these are pointing up or pointing down. So on C1, even though this is equatorial, it's pointing down. And on C2, also equatorial, but that one is pointing up. To draw the ring flip, we notice that carbon 3 is going to pull down, carbon 6 is going to pull up, but we don't even really need to pay attention to that yet. We just need to draw the ring forms and all the bonds. So here are all of our axial bonds, and then all of the equatorial bonds. So those are all in position. And then we need to number the carbons. So again, coming back to what I just said, in this ring flip, carbon 3 is going to pull down, carbon 6 is going to pull up. That makes that carbon, that corner, carbon 3, and this corner, carbon 6. So the numbering 3, 4, 5, 6, 1, 2 is the way that that numbering ends up. You can double check this by saying, well, if I were to go from this conformer to this one, carbon 3 would pull up, carbon 6 would pull down, and then that would give us the original structure. The next thing we need to do is put the substituents on the proper carbon numbers in the proper direction. So we have a chlorine on C1, which is way over here. It's kind of unusual for our drawings, but there it is. Chlorine is on C1, pointing down, and the fluorine is on C2, pointing up. Okay, and notice that originally they were both on the equatorial positions, and they end up both on the axial positions. So that all works out. And our final perspective of the day. Yay, we made it. Number our carbons. Check what is happening at C1 and C2. So C1, the substituent is pointing down. C2, the substituent is pointing up. Wait for it, we're almost done. C1, chlorine, and C2, chlorine.